Welcome to Tech Check. I'm Matthew Watkins. I'm with MCTC at the Maysville campus. I'm the HVAC instructor for that campus. And we got to talking, and we thought there's a lot of homeowners that have a lot of questions. A lot of people have a lot of questions. How does my unit work and what goes on? So we just thought we'd key up some videos and do these to answer some of your questions. And we've got a few things to get started by, but if you've got questions, hit us up in the comments. Let us know what is it you want to know, and we'll try to answer those questions. This is Adam Hawkins. Introduce yourself.
Yep, Adam Hawkins. I'm the HVAC instructor on the Montgomery campus here in Mount Sterling. I've been here this is finishing my 8th year, so done this quite a bit. I'm also a contractor, have my license, my master's license, so I am out in the field, and there are a lot of questions that I get, from time to time, that I just realize after a while, people have the same questions over and over, and so if, we as educators have the ability to kind of answer those before you call somebody, maybe to either let you know when to call someone, or maybe to prevent you from having to call someone, maybe just to know what's normal and what's not. How your system works and those sorts of things. What type of system that you have. How long should your system last? How do you operate a thermostat? How do you change your filters? When should you change your filters? Where are your filters? So those are all questions that I get asked quite a bit. And you'd be surprised at some of the things that you would think are very common when you do this for a living. And then, when you go in the general public, you realize that there's things that I think is common, and I tell my students this all the time. Just because we think it's easy doesn't mean that everyone does. This is what we do for a living. So, we spend our lives devoted to this, and most people, this is just a part of their home, just like their oven, or a part of their life, like their car is. So that just because they drive a car doesn't mean they know how to work on one. So that's kind of where I think this is going, just to kind of give you a little bit of an idea, a little bit of reassurance that maybe things are okay, or maybe you do need to call someone, because that's a big hesitation, is just, is this something I even need to call someone over? Because they know that, when a technician comes, it's going to cost money. It's a very high demand field. All of our students go to work for companies that pay them pretty well. And so in order for them to be paid well, they have to charge, and they charge, quite a bit. So before you have that hesitation of thinking, well, maybe I don't need to call someone, maybe we'll give you a little bit of information to know when you should, when you shouldn't, how to identify a problem, some preventative maintenance that you can do on your own that might save you a little bit of money, but also when to draw that line to say, no, this is something someone else needs to do. So, it's a great field, and I will say that if anyone that or anyone that you yourself, maybe you're interested in a high demand field, and as a homeowner, you see the demand of that, because try to get a technician to come to your house right now when it's 90. They're backed up for days, and very, very busy it is. So it is definitely in demand. You get your bill, that it's there's some money in it. There has to be. So we're also here to help answer those questions as well. So like Matthew said, any questions you'd have, comment, message us, message MCTC, and we have information about those programs, information about those careers, and maybe a little information just to help you out in your daily life. So that's kind of where we see this going.
One of the things that I think about, everybody's used Google Maps, and you bring up a Google map and you see these huge cities, or you see these huge subdivisions. Every building you see in that picture, it's got an HVAC system in it. So to say you're in high demand, yeah, you're in high demand. And not only are we here to kind of help educate you a little bit, I'd say we'll probably learn something along the way or two ourselves.
For sure.
First of all, how does an air conditioner system work?
Magic. That's what I usually say. So the common misconception that I hear, so this is something that I ask my students day one. I don't know, Matthew's newer to the teaching thing, but he's caught on pretty quick. So it's fun to start and remind them that, maybe they don't understand everything, but to show them where we're going. And then when they get to the end of the program, let them read back the things that they wrote day one and say, wow, have a clue, but now look at where I am. So it just gives them a little spot in the road to say, this is where I started and this is where I am. Because I think as instructors, we're constantly teaching them new material. And I always remind them that they may feel like they're constantly confused, or they're constantly behind, or they never just get to keep going over the same thing because there's always something new. But you are crossing, mile markers everywhere you go. And you can come back to that and say, okay, I understand how to do that now, but now I'm confused on this new thing. But when you get to the end of the program, or the end of the year, or the end of the class, and you kind of do a review, and you realize the things that now they understand, it's kind of a wake-up call to say, wow, I really learned a lot. So that's one of the big things I ask is, how do you think your system works? And I always get some really awesome answers. In the comments, if you're brave enough to do so, you could put in what you think or what you thought before we tell you. So how do you think it works? I get a lot of words that are partially there, compressors and capacitors and freon, and it makes cold. That's the biggest one.
Gas makes it cold.
Yeah, it's got freon, and that freon makes it cold, and it cools your house. So that's probably the biggest misunderstanding, I think, is that it's cooling your house. But
in reality, we can't make anything cold. But what we can do is absorb heat. So
Thermodynamics,
yeah, exactly. That's where we start. No,
I teach them thermodynamics day one, and I tell them to go home and just say, you can tell your family that you learned thermodynamics today.
Yes.
And so yeah, it's always kind of fun to put a big title on that, but basically it's the movement of heat. It's the transfer of heat from one place to another, because energy, heat cannot be created or destroyed. That's one of the laws that we go by. So
and it's always going to go from hot to cold.
Yep.
It's always going to travel from hot to cold. We don't go the other way. So do we want to actually kind of get into how this system's working now?
Sure. Yeah, we don't even turn it on right now, but this is a basic, what you would have in your home. Indoor, so we've kind of got this trainer set up to where it simulates inside your home, outside your home. This is something that our students use. And this would be your indoor system, where it might be located. So that's a good question. Where could my systems be located? Because if I'm out doing a call, a lot of times I'll say, oh, where is your air handler, or where is your furnace? And they'll be like, well, the air conditioner's outside. So this part is the thing that you may see at your house. And there are different variations of these, and there are some different configurations, but that's probably the most common, is what we would call a split system.
Yes.
So we'll get into, I think in the next, is like identifying what type of system you have. But just to see like where they are, where they're located, it always surprises me that maybe they don't even, the customer doesn't even know that they have a second unit. Yes. Because it's in the attic, or it's under the floor. It's in a place, in a closet that they don't check very often, and so it's in the basement. So this could be located in a number of different places, but this is going to handle your inside air. So this is what we call an air handling unit, or an air handler. So Matthew?
In this particular one, your fan, your indoor fan, is actually in this section up here. And then down below, we have what we call an A coil. There is various ones, but for this, so what this will do, like Adam was saying, it could be under the house in a crawl space, could be in your basement, could be up in your attic doing the second floor. There's a number of places that it could be, or just maybe in an alcove or closet inside your home. But this fan inside will actually, with ductwork that's installed, will actually circulate the air inside your home. This particular unit is what we call an upflow. It will actually move the air upwards. There's others that can be mounted in different configurations, but for this one, it's going to pull return air into the bottom, and it's going to pull that air over the coil, which is where it will absorb heat into the refrigerant that runs through your refrigerant lines. And then that air will be pushed out, cooler air will be pushed out into your home. So When it comes across this A coil, that refrigerant is actually a liquid at the time. And that's where the magic really happens, I guess you should say. This will absorb the heat within that air and transfer it outside to the outdoor unit where it will get rejected, brought back to a liquid, and the changing of the states is really what allows this to be very efficient. But then it's brought back as a liquid again, and the whole process starts over again. The condensing unit is where you're going to reject that heat out into the outdoors, and can kind of explain that.
Yeah, so you've got your A coil, your evaporator coil that's inside, and like you said, it's colder. So hot goes to cold. That's one of the first things that we teach is hot goes to cold. That's the way the heat travels. And so really what this process does is it just mechanically makes nature happen like it wants to happen. Hot goes to cold, things like to be equalized. Your home, even if it's insulated really well, without some sort of mechanical cooling, mechanical heating, eventually, even with the best insulation, it's going to equalize with whatever it is outside. So if it's 90 degrees outside, even the best built homes eventually will become 90 degrees because nature hates imbalance. And so it's this process of basically trying to fight nature. Heat going to cold, my house is 70, it's 90 outside, heat's trying to get in. In the wintertime, heat's trying to escape because heat is trying to go to a colder place. And so, I always use the example of your mom saying close the door because, you're letting all the cold air in, or you're letting all the cool air out. And actually it's the other way around. You're letting the heat out in the winter, or you're letting the heat in the summer. So, if a room were cold and outside were warmer, eventually it would equalize because the heat comes in, not because the cold escapes. And so what we're trying to do is we're just basically trying to fight that. We're trying to stop the heat transfer from coming in. I use the example of a leak in a boat. And so if you're out on a small boat and it's got a leak in it, as long as you can keep the water out of the boat at the rate that it's coming in, you can stay afloat. And so essentially your air conditioning system is a bucket that bails water out of the boat. So heat is leaking in at a certain rate, and every home is different based on how they're built, how big they are, but they all have what we call a heat load. So as that heat is trying to come in, we're trying to throw it back out. And so the leak in the boat, as long as the leak in the boat is constant, or that we know how big that leak is, we can put a system in that's going to pump the water out forever. And it does it on its own versus having to turn it on, turn it off. It's automated. And so that's basically what the process is. It's collecting it in there through that colder coil, through the process of evaporating, without getting too technical. And then it sends that refrigerant that has the heat in it. So the heat goes from the air to the coil, from the coil to the refrigerant, because it can't be created or destroyed, it can only be transferred. And so it gets transferred into that refrigerant. As a result, that refrigerant makes its way to the outdoor unit. And so the outdoor unit consists of a fan on the top, which is the thing you'll probably see first off. You might see that running, and if you ever see it not running, that may be a cause for concern. We'll get into that later, but there's a compressor located down inside of this. That's probably a little noisier, maybe something you hear kind of makes more of a growling sound. So sometimes the fan may run and the compressor's not running. So that may be something that could be an issue that you may be able to diagnose yourself and know when to call someone. But that compressor takes that refrigerant and it compresses it. And so essentially, just like an air compressor would do at your home to pump up your tire, you take air in and you compress it, and by compressing it, you raise its pressure. By raising its pressure, you raise its temperature, because that's the way it works. And so they've just taken what nature does and they've made it work this way. And so by compressing that refrigerant, the temperature gets warmer. Well, how does heat travel? Hot to cold, right? And so if I can make this coil around the outside, kind of like the coil in there, it's full of refrigerant. If I can make that coil warmer than the outside air, then I can reject the heat from the warmer refrigerant because the air is cooler. And so the same way I did there, I made that coil colder so I could pick up heat from the house. Now I make this warmer. And so one of the things you'll notice is like you'll feel, maybe this feels warm in the summer, hot air blowing out. That's the heat that's coming from your house, being transferred through the refrigerant. It's not pumping air.
Yeah.
That air is not, you know, some people think that that may be the way that it works. Somehow that air is working from inside to here. It's not the air from your house, it's just the heat from your house.
Yes.
So the heat from your house works into that refrigerant, and then because the coil is warmer, that refrigerant rejects its heat to the air and comes out here. And so we always say refrigeration is basically the process of moving heat from somewhere that you don't want it, being in your home or in your cooler or in your refrigerator or in your car, to somewhere that you don't care. And so in this case, the somewhere that we don't care is outside, just getting rid of it. So we pick it up there, we throw it out to this unit, and it kicks it outside. So that's the process.
Good. Well, thanks for watching another episode of Tech Check. I'm Matthew Watkins.
I'm Adam Hawkins.
Thanks for watching. Hit us up in the comments. And if anybody's interested, please come by and take a look at their programs.
Yeah, if you have a student in mind, a child, grandchild, someone you know that might be interested in this as a great field to work in, or just as a homeowner if you're having some questions, we're here to serve you. So.